right, part two of this process, synthetic division. So we did a long division 2 videos ago in lessons 3 through 5. And if we're dividing by a linear polynomial, so something to the first degree, so not squared, cubed, fourth, or anything, just to the first degree, I can use synthetic division as kind of a shortcut. So I need to keep in mind that when I'm dividing by this linear x minus 5, that x minus 5 is a factor of the function. And if you remember back to factoring, whenever we had a factor, we set it equal to 0 and solve for x. So the 0 of the function is 5. And that's important because that's the number that's going to go on the outside of my box for the synthetic division. The 5, not the negative 5, the 5. Because it's a factor, I have to create the 0, and you'll see in the module it says in the big bubble 0 is 5, and explains at the top in the remainder theorem why that is. So I'm going to set up my box. Dividing by 5, my coefficients are 1x cubed minus 2x squared minus 8x minus 35. Bring down the first number. Multiply, add, multiply, add, multiply. This time I'm going to put a box down here. And if that's 0, that means I have no remainder, and that is a true factor of the function. If I had a remainder, then x minus 5 would not be a factor of the function, as it did not divide into it evenly. So now what this 1, 3, and 7 represents are the coefficients of the polynomial that's left. So I started with a cube. I'm going to drop 1 degree. So now this is going to become 1x squared plus 3x plus 7. So that's how I divide and get my quotient. The 1, 3, and 7 become the coefficients, and my variables just drop 1 degree. So I started out with x cubed. So now I'm going to start out with x squared and go down by exponents by 1 to get my coefficient. So in the second example off to the right, x plus 2 is the factor I want to check. So I'm going to put negative 2 on the outside. My coefficients are going to be 1x cubed plus 1x squared minus 5x plus 3. So I'm going to bring the 1 down. I'm going to multiply, add, multiply, add, multiply, add. So now I have a remainder here. And I know traditionally, way back in elementary school, when you divided, you just wrote 12R2. And as you got older with long division, we carried it out until we got 12.5 or whatever it was. Essentially, all we're doing is putting this remainder over our divisor. So again, dropping 1 degree, starting with x cubed. So now I'm going to go down to x squared. So this 1 is now 1x squared minus x minus 3 plus my remainder, which is 9 over x plus 2, because I'm dividing by x plus 2. So it may seem a little weird, but if I do this numerically, 5 goes into 128, 8. 5 goes into 12 twice. Multiply. Subtract. 5 goes into 28 5 times. Multiply. Subtract. Instead of writing R3 or going to a decimal, I can take that remainder and put it over what I'm dividing by. So the answer is 25 3/5. You've probably been taught to take it out to a decimal, and 3/5 is 0.6. So 0, bring the 0 down. 5 goes into 30 6 times. So I still get 25.6. But to keep it as a fraction, all I'm doing is taking that remainder, which was the 3 here, and putting it over what I'm dividing by. So that's what I did with the remainder of 9. I just put it over what I divided by. So what you may not have been known you were doing all along, you've been doing all along. So the last one on this page is the try it yourself. So again, I'll give you a brief second if you want to pause and try it yourself. And then when you come back and hit play, I'll have the answer done out for you. All right, so I'm assuming that you've paused, or if not, you're completely lost at this point and you want to see another example. Remember this x plus 1. I have to set equal to 0. So the number on the outside is going to be -1. The 0 is always on the outside. My coefficients, 2x cubed minus 1x squared plus 3x plus 4. First number down, multiply, add, multiply, add, multiply, and I get my remainder. So my solution, I started off with x to the third. I drop 1 degree, so 2x squared minus 3x plus 6 minus 2 over x plus 1. These are my coefficients. This is my remainder. And they both lead me to my final solution. So that is synthetic division. The last part is we'll be using synthetic division to factor a polynomial, and that's on the next page. So I'll end this video so you can have some time with it, and then I'll start the next one so we're not rushing everything together. Part 3 coming up.